Hey guys, this is Mr. Teen Tutor, and I hope you guys are in the mood to analyze series circuits, which is a physics concept that, in my opinion, is kind of fun to do. So here's our series circuit right here. We have a battery of 24 volts, and we have 3 resistors, or if you don't like that word since it's too fancy, we'll call it light bulbs, with the following resistance values, and they're measured in ohms. That's the little weird symbol there. It's like a horseshoe almost. And what we need to do is we need to find the current for each resistor in the circuit, and we need to find the voltage of each resistor. Before we attack this problem, we need to understand some things about series circuits. We need to understand, first off, that let's call this resistor 1, call this resistor 2, and we'll call this resistor 3. So what we need to understand is that the current, which is represented by I and measured in amps, of resistor 1 is equal to the current in resistor 2 and is equal to the current in resistor 3. In other words, the current stays constant in a series circuit. We need to understand that the V source, or the battery, because the battery of course is the source for the circuit, is equal to the velocity, not the velocity, I must be still in a motion mindset, but we're dealing with electrons here, so this is different. So voltage 1 plus voltage 2 plus voltage 3. And we need to understand that in order to calculate current in the first place in the series circuit, you need to take V source over R. And R is the total resistance for the series circuit. So that's equal to resistance of resistor 1 plus R2 plus R3. So using these equations, we can solve for these variables right here. I'm going to erase this now, but as we go through the steps, I will write out these equations again so that you guys know when to use them and how to use them correctly. We begin with the first question, where we need to find the current for each resistor. So we need to utilize the equation I equals V source over R. Now we need to find the total resistance. That's equal to R1 plus R2 plus R3. So R is equal to, what's the first value? 2. And you don't have to write the units, but if you want to, you can. Just make sure that doesn't confuse you. Plus 6. So the total resistance is 10. And our V source is 24. So let's plug in some numbers. So I equals 24 divided by 12. And so I equals 2 amps. And then, like I said, amps are the units for current. So that means that the current in resistor 1 is 2 amps. In resistor 2 is the same, and it's the same for 3. Using that information, we will now try to find the voltage in each of the resistors. Keep in mind, of course, that I equals 2, because we're going to have to use that to find the voltage. Again, like I've said in a couple of my videos, when it comes to finding multiple parts of physics problems, you'll probably be using the answers in each of those things to find the answers of other things in the problem. So we're going to use the fact that the current equals 2 to find the voltage in each resistor. So let's remind ourselves that I equals 2A. Remember, A stands for amps. And now we're going to use the same equation, but because we're not dealing with the battery this time, we're kind of focusing on just the resistors and their voltages. It's just going to be V over R. So let's go to resistor 1. The current in there is 2. And that is equal to V over in the resistance is 2. So now you cross multiply. 2 times 2. So the voltage is equal to 4. And make sure, of course, you now include the units. So we found out 1. Let us now figure out what number 2's voltage is. Again, same equation. I is 2, and that is equal to V over, and this resistance is 4. Again, cross multiply, so V is equal to 8. And lastly, we will find the voltage for the third resistor. So 2 equals V over 6, so V equals 12. There you go. I found the current, and I found the voltage for each resistor. And when you're checking your work, you want to make sure that the individual voltages add up to the battery. 12 plus 8 plus 4, that's 24, so that makes sense. And you also want to make sure that the currents are the same for all 3 resistors because we're in a series circuit. That happens to be the case, so this makes sense and is right. So I hope this video has helped you, and in my next video we will talk about how to do parallel circuits. It's going to be a bit different, and it may be a little bit more challenging in some ways, but it shouldn't be too bad. So you should watch the parallel circuits video after this.